Good morning, everyone. I wanted to go ahead and do a follow-up on the lab that I asked you guys to do. Um, I had asked you to do the video, to follow along with it. I asked you some questions on it, and specifically I asked you for an LOL diagram based upon this video. I think, yeah. Okay, so I'm going to walk you through part of the lab. I'm probably just going to summarize it. I don't think I'll go through every last aspect of it. I'm just going to pay attention to the stuff I really think is important. So this website we'll probably use a couple times. It's all right. I love the videos. I like a lot of the tools they give us. It's just really awkward to do some of the other stuff. So I don't know. We'll decide. All right. So we got a bunch of water in a tube. You can even tell how much, 500 milliliters. We have 500 milliliters of water, and we've got this little burner full of pentanol. Now you can do different fuels in here if you want to. So like we've used ethanol in this class. There's octanol. There's all sorts of stuff. So like ethanol is something that goes in your cars and stuff, and we can watch that burn. So start off with 75.92 grams of ethanol, and then we start burning it. And look what happens as you burn it. See, isn't that kind of interesting? Watching that go down as you burn it. So 74.984 grams of ethanol are currently in this tube, and we are burning that right underneath this cup that contains 500 milliliters of water at 20.2 degrees Celsius. And we'll just sit here and watch it for a while. And we see the temperature of the water is going up. And that makes sense because there's a fire underneath it. And we see the mass of the ethanol is going down. And that makes sense because we're burning it. Now remember, the ethanol is not being destroyed. The ethanol is just being combined, reacting with the air, and it's going out and becoming a gas. All right, so the questions I wanted you to think about is what happens to the temperature of the graduate of the water? What happens to the fuel? Why does the mass go down? Eventually, what happens to the water overall? And then finally, where did the energy come from that is in the water now? And we're going to use all this information to help us make an LOL diagram. So I'm going to walk you through the LOL diagram and see what we can figure out here. So let's turn on. All right, so let's go ahead and make ourselves an LOL diagram here to match the video. So first off, let me try to remember exactly what we're showing in the video. We had water, and we know that the water's temperature went up. I don't remember exactly what it was, but it was something. And then down here we had the fuel, where the mass went down. Those are really the only two things we saw there, and we're going to try to put together exactly what was happening and put it all in an LOL diagram. Now, LOL diagrams only track energy, so we'll have to use the mass to help us think about what's going on here. So let's go ahead and make our L, and then our O. Oops. I didn't want to lock the way. There we go. I'm finally getting used to this little tool thing. It's kind of nice. And then we'll make another L right over here. We eventually do want this to be a two-step L, but we'll worry about that later. All right. So we know that the temperature is going up. The very first thing we're asked to consider is, hey, the temperature goes up. Let's show that. So how do we show that on our diagram? Well, I'm just going to show that it started off with a relatively low amount of energy stored thermally. I don't know, 2 boxes. and that it ended up warmer. So let's make it 5 boxes. 1, 2, 3, 4, 5. So we have more energy stored thermally afterwards than we did before. Which means, well, that energy had to come from somewhere. We must have put energy into the water somehow. Well, let's think. Where could that energy have come from? The only thing that's going on here, and if you have any experience with fire, you'll know this, is fire releases energy, but that energy is from a chemical reaction here. So we have a chemical reaction that seems to be releasing energy. So here our fuel with this flame must be putting energy into the water. Now before we start this, the fuel's not hot, all right? The fuel's room temperature, at least until it burns. So this energy cannot be energy stored thermally. It's not energy stored thermally. It's not energy stored in phase because this is not really a phase change. This is entirely a different chemical reaction. So this energy, whatever it must be stored some other way inside the fuel. We'll call this other way ECH. So this is energy that can be released or stored through a chemical reaction. And we'll think about what this actually means a little bit later. But there must have been energy stored somewhere else that we haven't seen in order for the ETH to have gone up. We did not warm up the water. The water got warmer because of a chemical reaction. Energy that used to be stored chemically must now be stored thermally. This is a really tricky concept and a really tricky idea. Some students will get it pretty much immediately, but some students will have to really roll around with this in their brain. If I wanted warm water, normally what I would do is I would warm it up somehow. Here, though, we are doing a chemical reaction to warm it up. I'm not putting outside heat into my system. I'm just taking energy that was stored, hidden away in my system, and somehow changing that to thermal. Now, eventually, if we let this water sit here on the counter for a while, and I'm just going to copy and paste this. Eventually it's not going to be hot anymore, right? It's not going to stay hot forever. It's going to go back down to room temperature, which was 2 boxes. I'm pretty sure those 3 boxes are just going to leave and they just won't be there anymore. Which means overall, if we look at our system, we had a bunch of hidden energy stored in that ethanol. It's not there anymore. Where'd that energy go? It was originally absorbed by the water, but then the water released it out into the environment, out into the surroundings somewhere. Overall, we have lost energy. Okay. There's yeah, I'll have to do a second intro video to this, but this sort of idea is something that we're going to be keeping track of. It does seem that there seems to be some way of storing energy that we haven't seen before. We will work out what this is over probably another video, and then it'll be part of our assignments going forward. And we're going to keep track of this energy using these LOL diagrams. If you haven't done the lab yet, please go back and watch the video. I know it's boring. It's literally just water sitting on a fire, but it's something we're going to be referring back to quite often. All right, everyone. As always, let me know if you have any questions, and have yourself a great day.